Good morning everyone, how are you all? Hope you all are fine. Okay, so today we are going to discuss about area of parallelogram and triangles. We studied before how the parallelograms and what the properties of a parallelograms are. Now today we are discuss about some more properties and the relationship between the two parallelograms and triangles. Okay, so this is your chapter number 9th of 9th class in NCERT book. So here we go. So first of all, we studied about what is parallelogram. We all know that a parallelogram is a figure, is a quadrilateral in which the opposite pair of lines are parallel and equal, right? Okay, so in this figure, look at this carefully. We can give the name A, B, C, D. Okay, if ABCD is a parallelogram, so that means we can say that these opposite pair of lines are parallel, or you can say that also if only one pair of opposite sides are parallel and equal, then also the quadrilateral will be parallelogram, right? Okay, so in this figure, let me draw again here. If you are taking this parallelogram and inside we can draw a triangle, we can give the name A, B, C and D. Okay, so you can see here, and this point we can consider as E. So now we can see in this figure that both these figures, that means the parallelogram ABCD and in the triangle ABE, both are having on the same base. What is the base? Base is AB. Is it right? You know all about what is the base. Okay, so if AB is the base and we know that ABCD is a parallelogram, so that means AB is parallel to CD. AB is parallel to CD, right? So these one pair of opposite sides, opposite lines are parallel as well as equal also, because if it is a parallelogram. So it is situating on the same base, which is AB, and in between the same parallel lines. Look at this, the parallel lines AB parallel to CD. Now these both the lines are in between the parallel. So that means here we can say that AB, because AB parallel to CD and both having the common base. What is the common base in this case? AB. Okay, so in exercise first, 9.1, you have to check that in which figure, or there are some certain figures, so you have to check that in particular which figures the common base are there and the line which are situating in between the two parallel. Okay, the particular figure which is in situating to two parallel lines. So we have to do that. What is this? So we can take here some more figures. Let's take an example of this figure. And here is another figure. The name is ABCD and here it is EF. Now can we say that these two figures ABCD and ABEF, they are having common base? Yes, obviously we can say that both the figures having common base, which is AB. But are these two figures in between the parallel? No. Why it's no? Because ABEF is not till CD. As we know that AB, if AB parallel to CD, that means this FE line should be up to here for being into the parallel lines. But in this figure, both the figures are not having in between the lines. So that's why these two figures are not in between the parallel lines. Okay, now let's take another example. If suppose this is a parallelogram, let's suppose it is a parallelogram. We can give the name A, B, C and D. Okay, and we are drawing a figure like this. Now in this figure, are they having or sharing the common base, and they are in between the parallel lines? Yes, we can say of course they are having common base. We write in initial form CD, common base. What is the common base? AB. Right? Now what are the parallel lines? If we can say that both the figures are in between the parallel, that means AB is having the parallel lines of CD. That means this triangle ABC is also touching the parallel line CD. That means they are sharing the common base AB till the parallel line CD. So that means yes, this figure having both these properties, that they are having common base as well as they are in between the parallel. Okay, let's take some other examples. Now tell me in this figure, if this is PQ, RS is a parallelogram, and there is another parallelogram PQRS, T and U. Are they having common base and in between the parallel lines? So we can say yes, because as we can see here, common base in this condition is PQ, because both the figures are in between these lines. So PQ is the common base, and both the figures are in between the parallel lines. These are the parallel lines. Look at this, and both the figures are having in between the parallel lines. Isn't it? Look at this carefully. PQ and SR or UT, they are all completely in between the lines. So we can say that yes, they are in between the parallel line, which are PQ parallel to SR, as well as you can say UT as well. Okay, so your exercise 9.1 is depending only in this questions that check in which figure there is a common base, and write the name of the common base, as we return common base is PQ, and which figure the lines, the two figures are in between the parallels. So if the figure is having the same property, then we can write in this figure the common base is this, and their parallel lines are these. So now we can take some more example. Look at this now. A, B, C, D. A, B, C, D, here also it is a parallelogram. Now we can make two triangles here. E and F. Now can you say that in these three figures, now there are three figures. One is ABCD parallelogram, and the twos are triangle AFB and AEB. Although they are having more than two triangles, but we are only consider these three figures. So can you tell all these are having the common base? As we can see here, they all figures are lie on the same base, which is AB. So we can write the common base here AB. Right? Now is these two triangles, we are talking about only these two triangles. So are these two triangles in between the parallel? So as we can see here, yes, in the triangle ABF, this vertex is also touching the parallel line, and ABE, this E point, this vertex is also touching the parallel lines CD. So in this figure we can say yes, they are having common base, and they are sharing the, they are in between the parallel. Okay, is this point clear? Alright, so we will move on now in exercise. Now in exercise 9.1, there is only these much points. Okay, there is only hardly 1 or 2 questions. Now in exercise 9.2 there are some practical question also, just like if this A, B, C, D is a parallelogram. It is given in the question that A, B, C, D is a parallelogram, and if it is a parallelogram, then there are some perpendicular, and here also a perpendicular is given. We can give it the name A, B, C, D. This is E and this is F. Okay, so if it is given in the question, this one is your question number first of exercise 9.1. If he is given that suppose AB is equals to 16 centimeter and the perpendicular which is on this base AB, this suppose you can say it is 8 centimeter. Now this BF you can take it anything like 10 centimeter, then find AD, A to D. If this side you have to find, then how we can find it? Now listen it carefully. Because it is a parallelogram, so we know what is the area of the parallelogram. We are finding the side and we are using area of the parallelogram formula. So we know that area of a parallelogram formula is solution area of parallelogram. In short we can write parallelogram as parallel NGM, base into height. The formula of area of parallelogram is base into height. So what is the base here? Base is AB, and the height means altitude. If you are finding, let's take an example, if you are finding the height of this, that means it is the altitude which is called height. Okay, so now in this parallelogram, the height which is on perpendicular to base AB, that means it is DE. Okay, because that is the perpendicular on AB, so height is only that. What is the name? DE. Okay, so therefore we get the formula of parallelogram is equals to base into height. Okay, now we know that there are one more base. We can say AD. If we are putting this figure into this way, into the vertical motion, I mean vertical way, then this will become base and this will become altitude, isn't it? So that means we can say area of a parallelogram. Here we write it AD into, because this will become base AD and the altitude will become BH, which is height, BF, which is equals to AB into DE. We can say that. Alright, because we know that area of a parallelogram base into height from this way, as well as if AD is considered as the base and this BF is considered as the altitude. Why we are taking this AD and BF? Because we know that if we have to find this AD, then we have to include this into the formula. Okay, so if this is the base, then this FB will be the altitude and height. From now here we can put the values and we can get the AD value. So AD, which we need to find, and there BF value is given 10 centimeter, which is equals to AB. AB is 16 multiplied by DE. What is DE? DE is given 8 centimeter. So now if we want to find the AD, that means we have to do the cross multiply of this 10, or we have to transpose this 10. So that means this 10 is in multiplication here. So when we transpose, we can put it down in denominator. So it comes down like this. Now you can multiply these value, or you can, if you want, then you can cancel out also. So one more thing is here. There is okay, no problem, then 8 and alright. Now 16 we are taking as a perpendicular base, 8, 6. So 16 into 8, 128 divided by 10. Okay, now if we want to divide it 10, that means it's quite simple. We can just put the decimal after one digit. So it is 128, then the decimal comes after 8, so it becomes 12.8, and the sides are in centimeter. So here also we can write centimeter answer. Isn't this question very simple? So in this case they are given the base and the perpendicular. Base and perpendicular, at least they have give you the two pair, base and perpendicular, and three things are given, so you have to find the fourth one by transposing it. Alright, shall we move on? Okay, so now we know that, or we study this point also, that if this figure, we can give a name A, B, C, D, if it is a quadrilateral or parallelogram or anything, right? If we join their midpoints AB, BC, CD and AD, if we join their midpoints, then the figure which is obtained, like we can give the name of these midpoint A, B, C, D, E, F, G and H. So if we join these lines, the figure which we obtained is also a parallelogram. That means E, F, G, H is a parallelogram. How to prove it? Because we studied in the previous chapter, chapter 8 also, and in this chapter it comes that if this is a parallelogram, so we can apply the parallelogram property here, and we can check that the particular base or these all things we will study it later on. But here we can prove that how this E, F, G, H is a parallelogram. So you all know that in this condition we have to draw the diagonal. What are the diagonals? AC, you can join BD also. So in these type of questions, when you have to prove that, prove E, F, G, H is a parallelogram or it's a rhombus or anything, so in these type of question, first of all you will write that what is the given, what are the given points in the question. So in the question it is given that A, B, C, D is a quadrilateral, so you can write only that A, B, C, D is a quadrilateral, where E, F, G and H are the midpoints of side AB, BC, CD and DA respectively. Okay, now these all are the given points. Now we need to prove that, what we need to prove. So to prove that, question is prove that E, F, G, H, E, F, G, H is a parallelogram. Okay, this is what we need to prove, and here we have to do some construction. For that we join A to C. This is not given in the question, we have to do by ourselves only. We join A to C. So write join A to C, and this, in this way only you will get the diagonal AC. So you can write it, draw a diagonal AC also. Now we come to know our main point. What are the proof for giving you that this is a parallelogram or not? So for that only we can say that it's a theorem that in a triangle, we'll write it here, if this is a triangle and these two are the midpoint of the line triangle ABC, this considered as X and Y. This X is a midpoint of AB and Y is the midpoint of AC if it is given. So when we join these two midpoint, then this line XY will be parallel and half of the third side, which is BC. So this is called midpoint theorem. We studied it before. So here also we can give the example. Here we can say that because E, F, G, H, it is written in the question that E, F, G, H are the midpoints. So if these are the midpoints, then here we join it, right? So that means this line in triangle ABC, if you are taking this triangle, here we go in triangle ABC. So in this triangle we can say that E and F, these are the midpoint of the side AB and BC. So if these two are the midpoint, and when we join it, it's automatically parallel and half of the diagonal, right? Because of midpoint theorem. So here we can write it in this triangle ABC, E and F. If you want to write it, then you can write it E and F are the midpoint of side AB and BC. Then EF will be parallel to AC, as well as EF will be half of AC, and this is our equation number first. Why it comes so? Because by, yes, midpoint theorem. We already discussed the midpoint theorem. Okay. Now we have to take another triangle. So after taking this ABC, what is triangle? Which triangle is left? This triangle ADC. So now we are taking this triangle also. In triangle ADC, so in this triangle ADC, we know that H and F, these are also the midpoint of the side AD and CD. So if we are taking these also, then this side GH is also parallel in half of the side of AC by midpoint theorem only. So here we write it G or H, or you can write HG is parallel to AC, and this HG is also half of AC by the same way midpoint theorem. Okay. Now from these two equations we can say that from equation first and second, are these two equations equal? Look at this. If EF is parallel to this one AC and HG is parallel to AC, that means indirectly these two sides are also equal. Look at in this figure, EF is parallel to AC, GH is parallel to AC, that both the lines are parallel to AC. That means these two lines, which is EF and GH, they are also parallel. So now we here written from equation first and second, EF is also parallel to HG. So that means these two lines are also parallel. Okay. Now after this, from these two equations only, as we can see that EF is half of AC and GH is also half of AC. Look at there, half of AC, half of AC. That means EF is also equals to HF. When your right sides are equal in the two equations, that means your left sides are also equal. For example, if you are saying A is equals to 2, B is equals to 2, that means we can say A is equals to B. Okay. Similar here. So these two are also equal. So here we write it that EF is equals to HF. So now from here, look at this observation carefully. We get to know that these EF and GH, they are parallel as well as they are equal. So what I said in the starting, that if the opposite pair of lines are parallel and equal, only one pair, if only one pair of opposite lines are parallel as well as equal, then the figure will be parallelogram. Because if one pair of lines are parallel and equal, then automatically the second one will be parallel and equal. Okay, it's not like that, say that in a parallelogram there is only one side which is parallel and equal. Both the sides, both the pairs lines are parallel and equal, but if one pair is going to be parallel as well as equal, then the second pair is automatically parallel and equal. So we don't need to prove that also, that this line GEH is also parallel and equal to EFG. Is that point clear? So now from here we can write, because we know that opposite pair of lines are parallel and at the same time they are equal, so we can say that EFGH is a parallelogram. Okay, so we know that if these two lines are parallel and equal, then the figure is obtained is a parallelogram. Alright, so now we prove that this is a parallelogram. Now we can apply the parallelogram property on this figure. Okay, for that we can do join this H to F, and we can observe many things here, but that all work we can do, we will do in next class. So today that much is enough. Alright, so thank you very much.